Okay, this is section 6.5, properties of logarithmic functions. Okay, so first we're just going to list some basic properties of logarithms. So for one, log base A of A. So when the base of the log and the argument are the same, this is equal to, and we can think about that. If I have x equals log base A of A, then I would say a to the x is equal to a, so what must x be? 1. So when the base and the argument are the same, it's equal to 1. If I have log base A of 1, and again, we can think about that one too. X is equal to log base A of 1. If I change that to an exponential expression, what must x be? Well, anything to what power would be 1? X would have to be 0. So log of any base of 1 is equal to 0. Alright, number 3. Log base A of A to the r power is equal to r. So when the base and the argument are the same, and the argument is raised to a power, then log base A of A to the r is equal to r. Now, similarly, if I have log base A of m to the r, this is equal to, that r exponent will come down as a coefficient. So this is the same as r times log base A of m. So, for example, if I had log base 2 of 5 to the third power, that's the same as 3 times log base 2 of 5. And I think that rule makes this rule, number 3, make a little bit more sense too. Since we know log base A of A is 1, when you bring that r down as a coefficient, you would just have r times 1, which is r. Alright, so 5 and 6. Number 5 says log base A of m times n can be broken down as a sum. So log base A of m plus log base A of n. So when you have two things being multiplied here in the argument, you could separate that into two logs being added together. And if the argument is a quotient, I can rewrite this with subtraction. Alright, so let's put this all together. Alright, you'll be asked to expand the following using log properties. So we'll look at a couple different examples. And the MyLabs Plus for this section asks you to do quite a few of these. So let's look at the examples on our sheet. So number 1, we have log base 3 of 5x. So I'm supposed to expand this. So since I have a product here, I can rewrite this as log base 3 of 5 plus log base 3 of x. Okay, number 2. And I think with these, I would pause it and try it, and then you can see if you got it right. Log base 3 of 3x squared. Okay, again, I have a product here, so I can separate these with addition. Log base 3 of 3 plus log base 3 of x squared. Now you should always simplify too. So here you should notice that the base and the argument are the same. So I know that this is going to be 1. And this exponent will come down as a coefficient. based on one of the above properties as well. So this is the same as 2 times log base 3 of x. Okay, number 3, we have log base a of the square root of x squared plus 1. Okay, so now let's think about the properties that we have and how this might expand. Remember, I can rewrite any radical as a rational exponent. So this is the same as log base a of x squared plus 1 to the 1/2 power, and then I can take that 1/2 down as a coefficient. Okay? All right. Why don't you try number 4, and we can take a look at that one in class. All right, another way you'll be asked to do this is you'll be asked to write the expression as a single log. So you're more or less being asked to go the other way. I'm going to give you something expanded, and now you need to combine it back into a single logarithm. So, for example, you could be given, let's say, 4 times log base 5 of x plus 5 minus log base 5 of x minus 4 minus log base 5 of x minus 14. Alright, so first thing you need to do is, since I do have a coefficient and I'm going the other way, I'm going to take that back up and make it an exponent. So this is log base 5 of x plus 5 to the 4th power. And now these two logarithms are being subtracted from this one. So I will divide. So this will be divided by x minus 4. And then we still have minus log base 5 of x minus 14. So finally, I'll have log base 5 of x plus 5 to the 4th all over x minus 4 times x minus 14. Okay. And when you're asked to do this in MyLabs Plus, it will say simplify your answer. And by that it means if there's common terms that can be canceled, you can go ahead and do that, but otherwise leave your answer there in factored form. There's no reason to multiply that out. Okay, next. Let's talk about the change of base formula. So continuing on your study guide, I'm going to skip that example of the equation and come back to that. So let's focus in on that change of base formula, where it says if y is equal to log base a of x, then y is equal to log base b of x over log base b of a. So I wrote log of the argument over log of the same base over the base. So this came from the argument, this came from the base. Now, 9 times out of 10, you're asked to do this so you can identify the value of a logarithm using your calculator. So when you use change of base formula, you typically want to use the common log because you have that button on your calculator, which is understood base 10, or the natural log, again, because you have that button on your calculator, understood base e. But it doesn't matter which one, they will both give you the same number. So if you look at the example on your paper, it says use a calculator and the base conversion formula to find, let's see, it says log base 9 of 71.3. So what I would do is pick either log base 10 or natural log. So I can rewrite this as natural log of 71.3 over natural log of 9. And then plug that into my calculator. I get about 1.942 if I round. Or, again, you could have used common log, just log, meaning base 10, 71.3 over log of the base, which was 9. And again, when you plug that into your calculator, you get the same value. So change of base formula is just a way to get a value for a log with a known base and argument using your calculator.